So here what we see is we see parentheses, and anytime we have parentheses, we think about the chain rule. So it's not just an x inside those parentheses, it's more involved. It's pi x plus 1, so we need the chain rule. So there's two ways of doing this. You can memorize that cosecant of u, when you take its derivative, it will be equal to negative cosecant u cotangent u times u prime. And you can plug in all of that for u, where our u would be equal to the inner function of pi x plus 1. So if I wanted to memorize that formula, what I would have for my derivative here would be y prime is equal to negative cosecant of u, which is pi x plus 1, cotangent of u, which is pi x plus 1, times the derivative of u. Now, the derivative of u, pi x, is a linear term, so that would just be pi. The plus 1 would go to 0, so it would be times pi. So that's one way of doing it, is to just say, okay, I'm using the chain rule, so I have cosecant of u, memorize the formula, and go from there. The other way of doing this, or thinking about this, I should say, would be the inner and the outer function. So here what I would do is I would say, okay, I have y is equal to cosecant pi x plus 1. So my outer function is the cosecant, and then my inner function would be the pi x plus 1. So when I take its derivative, I'm going to take the derivative of the outer. So the derivative of cosecant is negative cosecant. I have to keep this inside fixed, times cotangent pi x plus 1. So again, what we are doing here is the same thing that we did over on the previous question, where we take the derivative of the outer, and this is keeping the inside fixed, and then we multiply that by the derivative of the inner. So my inner function is pi x, so the derivative of pi x will be pi. Okay, so either way you'll get to the same answer. And some people really like a formula. Honestly, I think that we have a lot of formulas to memorize, so it might be easier to just think derivative of the outer, keeping the inside fixed, and then times the derivative of the inner. So either way you will get to the derivative.